welcome. We want to look at the topic linear programming, okay? This is one of the topics that come in final exam papers, both paper 1 and paper 2. So, what is linear programming? So, we are saying linear programming is a method used to try to maximize or minimize a quantity given by a linear equation under certain restrictions or constraints, okay? So, in simple terms, we can say that this is a method used to find out on how to do something in a best possible way, okay? We can think of it as being a situation where you are given a limited number of resources to use, okay? And you need to do an optimum utilization of the resources to achieve the best possible result, okay? For example, here we can talk of, for example, if you want to make chairs and tables, okay? But you are given limited resources to use, okay? So you must know how many number of chairs you need to make and the number of tables using the limited resources for you to have a maximum profit, but also to bear in mind to have a minimum cost, okay? So you can use what we call linear programming. So this is how linear programming works, okay? So you can want to make chairs and tables, so you must know what number of chairs and tables to make, okay? Then you must also know the language and symbols used in this topic for linear programming, okay? It's very important, and this is the foundation that you must understand. So let us see how we can know the language that they use, okay? This is very important. So the language that is used in this topic is, so if you check this table, okay? If you check this table, this side you have language, okay? And the other side you have symbol. So if you see where they say the total number, okay? If you are taught in a question saying the total number, okay? For example, if you say that let X be the number of the chairs and Y the number of the tables, and they say the total number of the chairs and the tables. So you use this, okay? The X plus Y. Then if you talk of where they say should not be more, okay? Or not be more, okay? Not be more, the symbol is less or equal to, okay? Where you just see that. Then if you talk of this one here, at least the symbol is greater than or equal to, okay? Then when you talk of at most, the symbol is less than or equal to. And when you talk of not exceed, okay, should not exceed, the symbol is less than or equal to. Then when you talk of maximum here, the symbol should be less or equal to, okay? Then when you talk of minimum, the symbol should be greater than or equal to, okay? Then for less than, it's just less than. For greater than here, it's just greater than, okay? So these are the symbols that we must know. If you just see this language, you must be able to know the symbol that you should use, okay? This is the basic and the foundation of this topic. Once you understand this, then you will not have any problem. And this topic, it will be a straightforward thing for you, okay? So it's important that we know the language and the symbols that we can use to represent the language that is being used in the question, okay? So now we go to our first example. It's from a past paper. Okay, so the example is saying that Kunika wishes to build a lodge with single and double rooms. He needs to decide the number of each room type he should build to maximize his profit, okay? Let X represent the number of single rooms and Y the number of double rooms. For A, it's saying, write the inequalities which represent each of the following conditions. Number 1, there must be at least one single room. Number 2, there must be at least 10 rooms altogether. Number 3, the total number of rooms should not exceed 15. Number 4, the number of double rooms must be at least twice the number of single rooms. Number 5, the number of double rooms should not be more than 12. Okay, so how do we do this? So let us look at the solution. So the first thing is that if you check here on top, we have been told that, if you check here on top, we've told that let X here represent the number of single rooms. Okay, so here, so let us say here we've been told on top that let X represent the number of single rooms. Okay, and let Y here, let Y represent the number of double rooms. Okay, here. Okay, so that's for Y. Then how do we solve this question? Okay, so if we are to start with the first part, okay, so here the first thing first is that we have been told that the X should be the number of single rooms. Okay, let X be the number of single rooms and Y the number of double rooms. Okay, so this is the first thing that we do. Then if we go to the first question, there must be at least one single room. Okay, there must be at least one single room. Okay, so here the language they are using is there must be at least, that is the language. And the X here, we know that it stands for the number of single rooms. Okay, so the number of single rooms is X. So meaning the first inequality will be the number of single rooms, okay, should be at least, okay, this is a symbol, should be at least one. Okay, so that is important. So the number of single rooms. Okay, let us go to number 2. There must be at least 10 rooms altogether. Okay, meaning the number of, now this word, the altogether, means the sum of the number of single rooms plus the number of double rooms should be at least 10. Okay, so this is what we're doing here. So for X, this is the number of single rooms plus Y, which is the number of double rooms, should be at least 10. So this is the symbol for the at least. Okay, so that's what we do. So this is important. So the X, which is the number of single rooms plus the number of double rooms, Y, should be at least, this is the symbol here, should be at least 10. Okay, this is how you write the inequalities. Let us go to the third one. The total number of rooms should not exceed 15. Okay, the total number of rooms should not exceed 15. Now, should not exceed, we said this symbol should be less or equal to. Okay, so the total number, then if you talk of the total number is the summation of the number of single rooms, which is X, plus the number of double rooms, which is Y, should not exceed, which is less or equal to 15. Okay, so this is how we do it. So this is should not exceed, which is less or equal to. Okay, so this is how you do the third one. Let us go to number 4. The number of double rooms must be at least twice the number of single rooms. So meaning the number of double rooms should be twice, okay, the number of single rooms. Okay, meaning we have more double rooms than single rooms. Okay, so here now the way we'll do this one, we'll say, so we are saying the number of double rooms, which is Y, should be at least, that's our symbol here, should be at least more than double the number of the single rooms, which is X. Okay, so that is how we do it. If we go to number 4, the number of double rooms should not be more than 12. Okay, should not be more than 12. So the number of double rooms, meaning Y, okay, the number of double rooms, which is Y, should not be more than, so should not be less or equal to, so should not be more than 12. Okay, so this is how you do it. Okay, so this is how we solve this question. So this is a past paper for 2019, paper 2, the first part of the question, okay? So this is how the question was supposed to be solved. Thank you for watching. See you in the next video. Bye-bye.